Okay, so for this video, we are going to go over the simplification of surds. Now this one is more like without a calculator type of question. So if you do use a calculator, you can literally just get the answer straight up. But usually, if you don't use a calculator, you will need to know how to manipulate, right? Because sometimes when you're able to manipulate, you're actually able to simplify expressions which include fractions, which we will get to later in this video. But for now, let's learn how to break this stuff up. So if I were to tell you the square root of 72, how are we going to simplify this without a calculator? So obviously the question is to simplify this value, the square root, right? Because it's a simplification. So from here, all we need to do is we need to realize that we can break this value up inside of this thing, right? We can break this value up into this. So 72, we want to write it into a form where we will have maybe any other value as well as a perfect square multiplying by that value. So if I were to say 72, this could be rewritten as 36 multiplied by 2, right? So what you notice is from here, if we look at a surd, right, we know that a surd is actually the same, or the square root is just the same as saying this entire value, 36 multiplied by 2, is raised to the power of a half. So we can use the exponent laws that tells us that we can distribute the exponent within these values. And therefore what we are going to be left with is 36 raised to the power of a half multiplied by 2 to the power of a half, and that is what we are going to have for this one here. But remember that anything raised to the power of a half is the same as the square root of that value. So therefore 36 to the power of a half is just the square root of 36. I'll explain why I'm doing all these details. Multiplied by the square root of 2, because it's 2 to the power of a half. And we know that the square root of 36 is just 6, because remember 36 was a perfect square, and I said in the beginning we need a perfect square to multiply by another value so it can simplify further. And this is the process where we simplify. We know that the square root of 36 is just going to be equal to 6, and we are multiplying it by the square root of 2. Okay, now that was the very long method of doing it, because guess what? I included this step over here. Okay, we didn't have to include that step, but I'm just trying to say that this is a direct method of saying if we do this question, square root of 72, we can rewrite it as the square root of 36 multiplied by 2, and we can use the properties of surds to imply that we can break, so that we can break the surd up because of the multiplication sign. If there was also a division sign, if there was also a division sign, we could also further simplify it from there. Okay, but from here we can go straight into the breakup multiplied by root 2, and therefore this will also give us 6 root 2. But I'm trying to show the steps on why this property works. Okay, so usually you would use this step right here. Okay, that was the first one. Let's actually go into another type of question, but let's make it a little bit more challenging. So for this question, I know I'm jumping straight into a fraction, but I want you to notice that it is not that difficult, because all we need to do is just look at the square root or the surd that we have here, right? We need to break the surd up. Don't focus too much on the other values yet, but let's focus on the surd first, because that is the problem we need to deal with. So 6 plus the square root of, remember in the first one we broke it up into a perfect square multiplied by another number. Now how do we get a perfect square from 18? Do you notice that if we divide 18 by 2, so 18 divided by 2, we get 9, right? So therefore this actually just implies to us that if we can convert 18 by when we multiply both sides by 2. So therefore, it's going to give us 18, it's just equal to 2 times 9. And notice that 9 is just a perfect square, which is just equal to 3 square. Okay, I know that was a weird analysis of the whole thing, but just to show you, you can break up 18, or you could literally do the table, the tree that you guys usually use. So you say like 18, you will get from saying 2 and 9. So this is 1 and 18, 2 and 9, and then you'll get remainders from there. But you can also do it like that. That one's more simple. Usually I like to analyze things. So yeah, let's continue here. So we can break it up into 9 multiplied by 2. Okay, I'll just say 9 like that. Divided by 3. And notice that we can use the separation rule from surds. 6 plus the square root of 9 multiplied by the square root of 2 divided by 3. And this can be written as 6 plus the square root of 9 is just equal to 3 multiplied by the square root of 2 divided by 3. And what do you notice? We can actually simplify it. There's two ways you can simplify it. Either you can take the first term and divide it by the denominator, and then plus it by the second term divided by the denominator, or you can take out a common factor. I'll show you both steps right now. So this is step number 1, right? So step number 1 is to use this method. We take the first term and divide it by the denominator, so 6 divided by 3, and then separate it by the sign that we have, which is plus, and then we take the second term and divide it by what we have in the denominator. So it's 3 multiplied by root 2 divided by 3, which this will simplify as 6 over 3, which is 2 plus 3, this can cancel, so we'll be left with root 2. The second step that we can take is usually the factorization method, right? So we can take out common factors and then we can solve the problem from there. So this is what it's going to look like. So we notice in the numerator that a common factor is 3. So we take out 3 as a common factor and we're left with 2 plus root 2. Remember the remaining values divided by 3, right? So I'm going to write that a little bit better. Divided by 3, and this is just equal to, you see that the 3's will cancel out, and they will be left with 2 plus root 2. So obviously less of a workout than the other stuff, but both of them work for this example. Let's move on to another example. This one is actually quite easy. Okay, so this one looks a little bit more intimidating, but remember that, okay, we have a surd inside, right? So before we can get to that one, let's first expand this bracket. We know that if we square any bracket, it can actually multiply by itself twice, right? Or once, sorry. Minus root 8 multiplied by 3, root 3 minus root 8. Okay. Or you can also do that, but usually I would say not yet. Okay, so here we go. From here, this is what we are going to do. We are going to use the FOIL method. So we're going to take the first term of each, and then we are going to say, let's say the equal sign here, and then we're going to say 3 root 3 multiplied by 3 root 3. That's just going to be 9 multiplied by root 3 multiplied by root 3. For now, I'm just going to write it like this. We know that the 3's multiply each other to give 9. And then we're going to take the outer, which is the O in FOIL. 3 root 3 multiplied by negative root 8. So it's going to be minus 3 multiplied by root 3 multiplied by root 8. Okay. And then from here, we are going to take the inner. So it's going to be negative root 8 multiplied by 3 root 3. So it's basically just going to be the same thing here. 3 root 3 multiplied by root 8. Okay. And then from here, we're going to take the inner, and then it's going to be the last. Okay. So here it's going to be negative, and negative gives a positive. Root 8 multiplied by root 8. Let's just write it like this. Okay. So now we need to simplify. Notice that from our surd rules, right, if we have something as root 3 multiplied by root 3, so I'm going to say root 3 times root 3, we can write this as 3. So we can write this as 3 to the power of a half multiplied by 3 to the power of a half, right? And then from here, notice that this has the exact same bases, okay, from there. Because these have the same bases, we can add the exponents together. Therefore, we have 3 raised to the power of a half plus a half, and we know a half plus a half is just equal to 1, which is just meaning that this value is going to be 3. So the property says that if we are taking the square root of a value and multiplying it by the square root of the same value, the square root will fall away. Okay, because of these exponent laws, meaning what we are going to have is 9 multiplied by 3. Okay, so exponent laws helps you every single time. When in doubt, use your exponent laws. It will save you in the exam or test. So we're subtracting this by, so now what we basically did with the what we also trying to say, right, is, oh, also another way to look at it, by the way, if we say the root 3 multiplied by root 3, we can also look at it in the fact where we can take the values and put it in the same square root. If you remember from that last technique that we used to split it up, we're just doing it the opposite way. So now it'll be the square root of 3 times 3, which is equal to the square root of 9, which also gives you 3. So if you also want to look at it that way, you can also do that. There's many ways that you can do this. So therefore, I'm going to use this one, that method. So because the square root, they both have a square root, therefore we can actually put the values inside of that same square root. So therefore it's minus 3 multiplied by the square root of 3 multiplied by 8. Minus 3, but in this case, what I notice I actually notice something. We don't have to do it, but I'm going to actually go ahead with this one. You can actually take a common factor of this, and then you can just deal with these values from here. There's, once again, multiple ways you can do these questions, but let's just do it the way that I'm going to do it right now, for now. Okay, so we just do the exact same thing you did here with this one over here. Plus the square root of 8 multiplied by the square root of 8. Notice we have two square roots which are the same multiplying each other, therefore we will be left with the original value, which is 8. Okay, cool. And now from here we are going to have to simplify. So 9 multiplied by 3 is just going to be equal to 27, right? And this is minusing by. Once again, you can actually just take out the common factors, and then what you're going to be left with, once you take out the common factors, you're going to be left with negative 6 multiplied by the square root of 3 multiplied by 8. Okay. And then what I want you to notice, we can actually try and simplify the 3 times 8, right? So 3 times 8 is equal to 24. Okay. So this is now going to be adding with 8. Okay. Now from here, we have a square root that we want to simplify. So 27 minus 6 into, when we want to simplify square roots, we want to, within the square root, have a perfect square multiplying with the value. And what is a perfect square that we are going to get, right? If we say 24, right? So 1 goes into 24 times, okay? And here we have 2, we will have then 12. And if we look at this, we divide again, but we can do 3 and it will be 8. There's still no perfect square. So let's keep going. If we take 4, then what we are going to get is it's 6. Okay. So what do you notice here? Where is our perfect square? Our perfect square is actually 4, because 4 can be written as 2 squared, and we just need to multiply it by 6. Okay, so that's perfect. So that's what we're going to do. Multiply by the square root of 4 multiplied by 6. Okay, and then we're going to have plus 8. And we can do the breakup. 27 minus 6 multiplied by, then we're going to have the square root of 4 multiplied by the square root of 6 plus 8, And now we can simplify it further by saying 27. Well, actually, we can just take the 27 and we can add it with the 8 already. And 27 plus 8 is just equal to 35, right? And then from here, if we say the square root of 4, that's just going to be equal to 2. And 2 multiplied by 6 is 12. And then we're just left with multiplied by square root of 6. And that will be the simplest way that we'll get the answer, because from here, if you want to simplify this, we cannot get a perfect square out of this because we're just going to get 2 multiplied by 3 or 1 times 6. There are no perfect squares other than 1, but you usually don't look at 1 as one of the perfect squares that you want to simplify because it's just going to give you 1, right? And you're not going to make any progress. So that's basically how we deal with all of this. Okay, now this is the first time I'm going to do something like this, but from the knowledge that you have right now, from everything that we've done in the previous videos and this video, I want you to attempt this question. 6 multiplied by the square root of 2x to the power of 8 minus 2 multiplied by the square root of 8x to the power of 8, all divided by, or all over, the square root of 8x to the power of 8. I want you to try this on your own and then see where you get with this.